Okay, simplifying complex fractions. It's basically a fraction within a fraction. So I'm going to do like I would with any other problem. I am going to simplify the numerator. So I'm going to take 2 plus 3, and I'm going to get 5. Okay, now it's written like this, but it really means this. Which, when you're dividing, means to multiply by the reciprocal of that fraction. So 5 times 5 fourths, so 25 over 4. Okay, do the same thing here, but now I got to simplify the bottom fraction first. So I'm going to find a common denominator between 4 and 5, and it's 20. So I'm going to multiply the first fraction by 5s, the second fraction by 4s. So that's 5 over 20 plus 12 over 20. Okay, so 17 over 20. And this time, though, instead of rewriting it like I did there with old school division, I'm just going to recognize that I'm going to multiply by the reciprocal of the bottom fraction. So I'm left with 5 times 20 over 17 to simplify, because all that just is canceling out over 1. So 5 times 20, that's going to give me 100 over 17. Okay, so here I'm going to do the same thing, but with polynomials. I need a common denominator, so because I need to add these two fractions in the bottom. So I'm going to multiply this fraction by x, and I'm going to multiply this fraction by x plus 2. So 2x, 2 over x plus 2 from the top stays there. I've got x on top plus, and again I got to distribute. So 2x plus 4 all over x times x plus 4. 2 rather. Okay, do a little simplifying here. So let's go x plus 2 over 3x plus 4 all over x times x plus 2. I'm going to run a room here. So remember, it is this basically 2x plus 2. That top part of the fraction stayed exactly the same. What I'm going to do is I'm going to take right here, and I'm going to take the reciprocal of that and multiply. And if you notice, I've been leaving the x outside of the parentheses of the x plus 2 for this. Okay, look, x plus 2, they cancel out, so we're left with 2x over 3x plus 4. And there you go. These two x's can't be touched because they're separated by addition. This is 3x plus 4. Okay, so let's kind of keep on going again. The only difference with this guy here is that and I'm kind of sick of this red color, I'm going to find a common denominator, so it's going to be 5. So x plus 2 minus 25 all over 5. 8x plus 4 all over x. So a little simplifying, so it's going to become x minus 23 all over 5. And it's always taking the reciprocal of the bottom fraction. Okay, there we go. I'm going to just factor this 8x plus 4 just to check, but I'm pretty sure the 2x plus 1 doesn't show up on the top, so I'm off that as is. You can multiply through, but I'm fine with factored form, so x times x minus 23 on the top, and the bottom 5 times 4, so 20 over 2x plus 1. Again, you can distribute those if you want, leave it that way as well, but I'm fine with you keeping it that way. Same thing, top one doesn't have a greatest common factor, but what I'm going to do though is I'm going to factor out the 2. I see a greatest common factor in that. Right, 2x plus 1 is 2 parentheses x plus 1. Here I need to multiply my first fraction by 2 and my second fraction by x, so minus x all over 2x. Okay, multiply by the reciprocal of the bottom. Okay, and I notice here that this 2 and this 2 can be reduced. So I've got 15x all over x plus 1 and 12 minus x. Again, factored form is just fine. All right, complex fractions. So I got one more here to shoot for you, just because I like to practice a little bit of the adding with two, well, I guess it'd be binomials in the bottom here, but that's kind of technical. But I'm going to combine by adding these two, so they need to both have the exact same denominator. So this one's missing the x plus 1. This one's missing the x minus 4. Okay. So the bottom looks something like this. I've got x plus 1 plus, and I'm just going to distribute the 3 right away, plus 3x minus 12 all over, and I'm not going to multiply out the denominators. Okay, simplify the fractions a little bit. So there's the top one stays the same, and I've got, what, 4x minus 11 all over x plus 1, x minus 4. Yeah, again, it's the second one that gets flipped around. So I'll flip that second one around, and I'll show you why I'm not foiling the x plus 1 and x minus 4, because when I flip it around and rewrite it as multiplication, the x minus 4s are going to cancel out. So I've got 3 x plus 1, 4x minus 11. And that's complex fractions, okay? And remember, it's always multiplying by the reciprocal of the bottom fraction, the bottommost fraction or number.